Let us start our discussion on electromagnetic spectrum. An electromagnetic wave is produced when there is a discharging spark or oscillating molecular dipole. As the spark discharges or as the molecular dipole oscillates, magnetic fields and electric fields are generated simultaneously, producing an electromagnetic wave. All electromagnetic waves have similar properties. All EM waves are transverse waves. Electromagnetic fields and magnetic fields propagate perpendicular to each other, so EM waves are transverse waves. They all travel at the same speed in free space or in a vacuum, which is 3 times 10 to the 8 meter per second. They can travel in solid, liquid, gas, and vacuum. They can be absorbed and emitted by matter. They follow the laws of reflection, which is the bouncing of waves as they hit a surface. It can be demonstrated by this figure. When a signal is transmitted by a tower and strikes the surface of a building, it is reflected. In the ionosphere layer of the atmosphere, when the signal or the wave touches the ionosphere reflects the signal back to the Earth's surface. They follow the laws of refraction. Refraction is the bending of waves as a result of the change in speed as they cross the boundary between two media of different densities, similar to this one. A wave transmitted by a satellite dish changes its path due to the change in speed as it crosses the boundary between the layers of the atmosphere. They exhibit diffraction. Diffraction is the bending of waves around corners. As shown in the picture, when the signal is transmitted and it hits or strikes the mountain causes the bending of waves so that the waves will bend and eventually reach the house or the consumers. They exhibit interference. Interference is the interaction constructively or destructively between waves. There are two types of interference, the constructive interference and the destructive interference. As you see on the screen, when two similar waves meet, they superimpose or they add, creating a bigger wave. When two waves are out of phase, they cancel each other's effect. Interference can be demonstrated using this example. Signals coming from two sources interfere with each other, causing a destructive interference, and the signal results to fading. They can be polarized. Polarization is the filtering of waves or changing the orientation of waves. In a military setup, information is very important to reach the home base. So, satellite dish are sending signals vertically and horizontally so that whenever there are blockages or hindrances, message can still pass through the hindrances, reaching the target location. Electromagnetic waves are arranged in an electromagnetic spectrum in terms of wavelength and frequency. You will observe that from radio wave, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays, The frequency is in increasing order, same as with the danger. Unlike the wavelength decreases from radio wave to gamma rays. Electromagnetic spectrum can also be categorized into non-ionizing or ionizing radiation. Specifically, extremely low frequency, radio, microwaves, infrared, visible, and some portions of ultraviolet fall under non-ionizing, and the rest of the ultraviolet, X-rays, gamma rays fall under ionizing radiation. Ionizing radiation will be discussed when we have our effects of radiation on living organisms. To end my session, think about it. Like EM waves, we have our distinct characteristics and properties from other people. So we need to respect a person's individuality. You may now proceed to your learning task for the day.